It's nice to see a good turnout again. We're obviously doing something right, and perhaps while we're on that theme, the committee's in the throes of trying to plan for next year. So if anyone's got any ideas of potential talks that they'd like to see, please let us know. In particular, if you've got any contacts who could give those talks, let us know, because that always makes it a lot easier. Our next talk is actually on the 18th of May, and that's delivering business value with Agile. So basically looking at Agile project management and the benefits of that. Today's talk is from Dr. Tom Kirkham from STFC, who will be talking about blockchain, and it's something that seems to have risen in its profile recently. So won't steal any of your thunder. I'll pass over to Tom. Thank you very much.
Thank you. Hi, so my name's Tom. I'm from Science and Technologies Facilities Council, and I work at the Hartree Centre, which is in the north. I'll give you a brief overview of the STFC, the different sites, what we do, why we're interested in blockchain technology. I don't know how many people here are familiar with blockchain technology, but I've been working around it for about a year and trying to figure out if it's any use for us, and every time I present on it, not many people understand it, so I try and go really slow, and I apologise in advance if it's a bit too easy for you, but then I'll try and go into some application areas, and that's where the real interest is. And feel free to interrupt and have a discussion or whatever. I don't know how long it's going to last for, but I'll give it my best shot. Okay, so STFC stands for the Science and Technologies Facilities Council. We're a research council with a big laboratory located not far from here, just away from Didcot near Harwell, called the Rutherford Laboratory. We effectively get grant proposals in from academia and other organisations to use our facilities. So our facilities generally are massive, big scientific facilities, and supporting those is a big challenge computationally, and that's where our computer science departments come from, but also technically as well. We've got a large amount of technology on site. So our main sites, other than RAL, we've also got Daresby, that's where I work currently now, which is near Warrington, and then we've got a few other sites such as some telescopes located in some sunny places such as Hawaii, and I think it's like the Canary Islands over there. Yeah, and we've got Swindon, yeah, obviously. Yeah, I don't know how that made it on last time. Don't make it look too exciting. It's funny to balance things out a bit. So they're our main sites. So I mentioned that we've been around for a while. Our history with computing has sort of grown up with the science. So about a year or so ago, my colleague Victoria Marshall presented on the history of the Atlas computer, and I helped her a little bit with that. And that was the first sort of big computer made for visiting scientists to use in the UK, probably in the world. And we had a big computer centre built flat called the Atlas Centre. And this is the log. This is sort of the first example of a distributed ledger, although there's only one, but it's shared around a lot. And this is where people logged their experiments that they're running on the Atlas computer, and testing that satellite, which was the first UK satellite in space, called Ariel 3, is logged in that ledger somewhere. I'll try and point it out, but I don't want to risk not being able to find it. And today, we're building this thing called the Square Kilometre Array. I think it's in South Africa, and that's going to generate, I think it's something like 2 times daily global internet traffic each day. So it's a huge data challenge there, and it's not just the data challenge in terms of storage and transferring the data. There's also a big effort being put on the hardware side, so how you sort of pre-filter it and set the rules, etc., when it's being received. So data, as you can see, has been part of our organisation from the start right through till now. It's a big challenge, and blockchain is related to data, so it's obviously of some interest to us. And that interest, from a scientific point of view, can be sort of crystallised in the thing we call the scientific life cycle, or scientific data life cycle, where we typically have our scientists write their proposal, get it accepted, come onto site, log the materials or whatever they're testing, run their experiments. Then we store their data and associate it with their experiment in a system called ICAT. We do some processing on site and allow them to run their own tools for visualization and understanding the results. And then we even go through to the publication phase and store the publications. There's been a large amount of work recently around digital object identifiers and how you sort of classify data the same way you would classify a physical publication. So if somebody does an experiment based on the back of previous work, they can reference the data objects from that as well, which is something that comes into the blockchain later. Now, the Hartree Centre is new, and it's located up in Warrington, and it's part of this thing called the Northern Powerhouse, which, because of Purdah, I can't really talk too much about, because it might either go negative or positive, and it's not really worth it. Anyway, so it's a centre of expertise for high-performance computing. We've had a huge investment from government. We've got a partnership with IBM, and we've got lots of different hardwares where we're basically trying to reach out. Instead of to academia, we're going directly to industry. So there's a big pharmaceuticals presence up near Warrington. So we're doing a lot of simulation around different computational chemistry problems and things like that. And we're obviously trying to make the most out of what we do, and we've got the mission to transform UK competitiveness by using HPC and data. And we're going into the area of cognitive computing, so that's machine learning and things like that, and that's obviously of interest to IBM because they've got IBM Watson. So the goal of computation from Hartree is to develop better products faster and cheaper, but we also help people with a whole range of different things in the business. So you're wondering where blockchain is. So blockchain comes into that area around sort of emerging technologies and proof of technologies. So within Hartree, we're starting to talk to SMEs who are interested in blockchain, and basically help them sort of write bids for funding. There's quite a lot of funding at the moment coming around that area, but also help them develop sort of test beds for it as well. So, and I'll talk a bit more about that in a minute. But the Hartree Centre is not going all the way to market. It's sort of based around sort of the pre-commercialisation work, sort of the proof of concept, the R&D phase of the work. So, right, blockchains. So, I use Lego just to show a blockchain. So, if you imagine, I'll start with a simple case. So, this is effectively 4 blocks of Lego. Data within a blockchain is stored in a transaction, which is then formed into a block. So that's one block, say 50 transactions. And then you get another block with a load of more transactions, and then the chain is the part where they fuse together to form a blockchain. Now, the way they're fused is fusing cryptography in mathematical equations, and I'm not a mathematician, I apologise for that. But it means it's a unique signature. So if somebody's got another blue and green block and they say it's the same as this one, there's actual things you can do to say whether it's not on, whether it is or not. And then obviously, the blockchain goes on and on and on and gets bigger and bigger and bigger. And it's shared between the whole network of parties. So that's in a nutshell how it works. Why it's better than centralised databases is because obviously within a client-server network, there's the server, and there's a lot of burden on the server. You've got all the data on the server, so it's a single point of failure. If it goes offline, all the client functionality goes offline. And also, you put a lot of trust into the organisation which sort of controls it. So I was talking about blockchains to an organisation a few weeks ago, and they said, well, is it just like Dropbox? So if you imagine when you share a Word document on Dropbox, if you're sharing it with about a dozen other people, you type some words into it, and it appears on their machines as well. And it is, in the sense, that level of sharing, so you can replicate things across a network of peers. But behind Dropbox there is a host, maybe Amazon Web Services or something like that. So you're putting your faith in that sort of service provider, which you might not necessarily agree with in terms of their data privacy policies and things like that if you're handling sensitive data. So the key thing about blockchain is it's peer-to-peer. That's the first step. So if you think about it, you've got different transactions and blocks, and they're all replicated between each node. Now the other one is when the blocks are fused, they're obviously done with mathematics, but also there's consensus as well. So within cryptocurrencies, which I'll come on to in a minute, you've got the process of data mining. So within that, you've got competing miners all trying to stick the next level of transactions onto the block, the common block that everybody holds. And the decision made as to what miner gets to stick the next block onto the chain is done through consensus algorithms, which basically within a cryptocurrency determine which miner gets rewarded for adding the extra block. But that doesn't have to be the case within all blockchains. You can create your own sort of consensus algorithms based on your own level of trust within your network. So if you've got a specific business problem that you want to solve by sharing data within a peer-to-peer network, you can develop your own consensus algorithms using specific types of blockchain software. And I'll move on to that as well in a minute as well. So unfortunately, I'll start with cryptocurrencies because that's what most people associate blockchains with. So if you didn't know about Bitcoin, it's a cryptocurrency. It was launched 8 years ago. It was the first one, but now there's lots of other different types of cryptocurrencies around. And one Bitcoin is now worth over $1,000, and its value's generally increased quite steadily over the last few years. And interestingly, it's moving away from what people associate its use with, which is sort of in the dark web, to more mainstream use. So I think there's a Swiss railway company that accepts Bitcoins. And I think you can buy quite a few services online, such as the Steam gaming system that accepts Bitcoins as well. The significant thing about blockchain in relation to Bitcoin is that blockchain is used to store all the transactions, as we've been looking at with the Lego, and there's millions and millions of transactions, and it's never been compromised to the extent where the currency's collapsed. So if you think about how you would compromise such a network, you would need to basically take over, because of the consensus algorithm works on a majority basis, and there's thousands and thousands of different peers, all part of the network. You need to take over a majority of the peers in order to sort of control which block gets accepted, so you can manipulate it so all your blocks get accepted and you get all the rewards. But by doing that, you would undermine the currency, so it's not worth it. But a big problem with excuse me if I get them mixed up, Bitcoin, is that the blocks, when they're mined, they're limited to 1 megabyte. So that means that there's lots and lots of different blocks within the Bitcoin blockchain, and it's a kind of a funnel effect. So when there's lots of high traffic and lots of high transactions, it can have a sort of slowing effect as the blocks are sort of queued in order to be sort of agreed to be added to the blockchain. And there's lots of, if you look online around this problem, there's lots of different posts talking about the politics behind it, and it all goes back to the consensus and how it was set up in the beginning. And it's based on the majority of the miners agreeing the rules onto how these blocks are added. And currently the majority of the miners, the vast majority of the miners, are located in China. And that brings it with a problem in the sense that the Chinese internet is not as fast as what we've got in, say, the UK, because it's behind what they call the Great Firewall of China. Some guy wrote about saying it's like trying to do Bitcoin mining over hotel wireless rather than normal kind of wireless. So it's within their interest to have smaller block sizes so they can quickly transfer them rather than larger ones, which has limited the scalability of this sort of network. Now, they're talking about mining. It's the key feature of cryptocurrencies because that's where the value is created. So typically within Bitcoin, it's through these mathematical problems which take ages to solve in order to take up computational resource, and that's generally referred to as doing the work. So that's putting the effort in order to get a reward out. in order, but that doesn't have to be necessarily related to the Bitcoin algorithm. Interesting in the Bitcoin algorithms led to the development of specific hardware to mine Bitcoins, which is a bit of a weird problem because it's unique to just mining those currency problems, which is not necessarily real world problems, but related to the currency. But there's other examples. So there's one where people mine the currencies by walking, or you could think of other ways of doing that kind of effort in order to get the reward. So those algorithms basically validate the transactions, add the blocks, and then within Bitcoin you get the reward, which is new Bitcoins created. And that, in terms of financial technologies, and this is about my limits of it, is called proof of stake. No, that's not called proof of stake, it's called the proof of work. Now, proof of stake is another way of doing it within cryptocurrencies, where all the coins are fixed at the beginning, so you've got a maximum amount of coins that can be generated, so it's not like Bitcoin where you generate new ones each time you mine. So when the blocks are created, the coins are taken away. And the blocks, instead of being mined through a high computational process, they're just basically put together quite simply in a kind of a forging way, where the miner pays in order to do it, and the algorithm is based on a bit about how much wealth the miner has in terms of the stake, but also a bit of randomization as well. So anyway, forget about all the crypto. That's all the cryptocurrency angles, which is sort of the foundation of blockchains, but it's really not where we're going to go with the blockchain story, as to why we're interested in it in relation to science. Is anybody confused at this point? You're very polite. So, moving blockchains beyond currency is generally referred to as distributed or shared ledgers. So, you've got your transactions and you've got them in blocks, which is the same as a blockchain, but effectively we refer to them now as ledgers, and they're distributed between the peers in the same way as they would do in a blockchain. So within this type of way of doing things is that consensus still exists, but as I mentioned earlier, you can define your own sort of consensus algorithms. So you can remove the scalability issues in relation to, say, the Bitcoin blockchain. You don't need to do big, high computational proofs of work. You could do other things in order to sort of determine as to what block goes on next. You could have a simple set of rules. You could have a blockchain set up between 6 people, and you could say, well, you could do it in terms of some kind of sequencing, or you could do it in terms of what's in the data that's being added. There's also other rules that people add to the blockchain as well. So the Bitcoin blockchain is all about transactions and putting them in a chain in order to basically show a big trail so you can validate the currency. Ethereum, which is another cryptocurrency, comes with a feature called smart contracts. So smart contracts, if you're familiar with sort of database triggers, in some old databases, you add some data, and if the data is of a specific pattern, it can set off a process which can do something else in the database. Smart contracts are similar to that in the sense that they can detect specific patterns related to rules, and if those patterns happen, it can then trigger off another process which does something else in the chain. And that's very important because distributed stroke shared ledgers are the application of the concept of the blockchain, which is applicable. It's going to be trying to apply to any other domain. So if you've got a very business-specific problem, maybe needing smart contracts or some other quirky thing within the sort of blockchain you're designing, you would create your own sort of form of distributed or shared ledger. So this is why it's significant anyway. So if you think about it, it's a way of achieving trust. And trust over time has been sort of slow to evolve. So with respect to transactions and sharing things, so if I've got I don't know, some Lego and I want to share it with my mate Ian, but I don't want him to pinch it, I could give him a receipt. But in Neolithical times, we'd use something called tally sticks. So they would get a stick or something with markings on and break it in two, and then in order to cash it back, they would come back and they would join together. So then you would have a proof that you'd made that agreement with that person, or that person holds the IOU or whatever's written on the stick. And that's been in place. That was in place for thousands of years, and apparently it's one of the reasons why there was a fire in Parliament, was there's loads stored underneath Parliament a few hundred years ago. But that evolved with the invent of is it double bind bookkeeping, double entry, yeah. So that's again, it's all about balancing who owes who what and who's made an agreement with another person. But then you can see your invoices and your outcomes, and you can balance them over. Now, all the hype associated with blockchain, this is why you probably hear so much about it, is that this thing's been so slow to evolve over time. And now people are saying that blockchain is the next step along this process, and it's the digital step. So you've had bone, paper, now we've got digital. So within a distributed ledger or a shared ledger, you've got the ability to say trace through the whole transactions and see all the different agreements. Or within a cryptocurrency, you can see where the money's been spent and where exactly trace it all the way through. Which is, it does all those things there where you can match up who owes who what and who's exchanged things with who. But you've also got the ability to mine vast amounts of data around specific transactions or specific business interactions, which can yield real intelligence. And that's where another big area of hype comes in, called big data. Which is something we're looking at as well. So if you think about, if you're a government and maybe we all switch to using bitcoins or some other cryptocurrency or distributed ledger to share government spending or government grants in the future, when the government comes up to present their figures and they start talking about, we spent, this is where I've got to be careful what's a per, I suppose, but the government makes a point about spending X, Y, and Z on this and that and the other, you could probably verify it using something like the blockchain. So then you could have like data-driven politics. Can you imagine what that would be like? We wouldn't even need to vote, we'd just set of preferences and let it go. Then no need to campaign either. So does that sort of make sense? You can see like the evolution. And because it's all about, balancing stuff out, is the application is way beyond banking. It can be any sort of form of asset sharing. So now this is why it's significant, drilling it down to sort of more specific points. So the key thing is the data is immutable. So if you're distributing it between enough peers, in theory, and the consensus algorithm is right, the records should always remain updated. Now, in the case of the Bitcoin blockchain, you can see that at the moment, there's millions and millions of different peers. So it's pretty impossible to sort of skew the records. Within a sort of smaller network, it might be a bit easier, but effectively the whole concept is that you never delete any of the records. It's not like a database where you clear out after 3 years or anything like that. It's from the beginning of time. And that's all due to the sort of cryptography and the way you hash and the way you sort of do the checksums, etc. on the blockchain in order to prove that it's actually real. So it's in your best interest to keep all the history. And as a specific point, the Bitcoin blockchain is about the same size as a DVD movie on your, it's a couple of gigs, so it's not huge. So you can put it on your PC. And you can add really any data to a blockchain. You can, I think you hash it and then you can encrypt it if you wanted to, but then you can add pointers to wherever it is. And then if you wanted to sort of prove that it was the data, you could then do the sort of references of the size of it, etc. Another significant thing is that it's obviously peer-to-peer, so you remove sort of the cost of the middleman, which is the case in banking where you would have somebody taking the processing fees. But you can also introduce third-party audits. So touching on science, if you've got there was a big, I wouldn't say big, but there was a controversy around the university, I think it was East Anglia, where there was some environmental emails that were hacked. And they were taken out of context to talk about global warming or something like that. You could log emails in relation to a specific research area or a specific piece of work you're doing on the blockchain, and then just open it up to one specific third party. You could validate them. Maybe emails is a bad example, but you could do the same with transactions to prove that your transactions are, say, above board or within specific rules, and the third party could audit them. And this doesn't necessarily have to be a person, it could be a machine, so you could, get the machine learning angle on it and all that stuff. Obviously, the consensus models is a significant area of blockchain, and that taps into trust. So you can, in terms of the consensus models, you can make it specific to the business network you're doing. So within the Bitcoin blockchain, it's related to the miners, the consensus, I think. But within, say, you've got a bunch of small to medium enterprises trading parts, and the consensus could be within 30 days the payments balance out or something like that. I don't know, I just made that up off the top of my head. But the trust is an interesting point, because in theory, because everyone's got a copy of the blockchain, all the transactions are open, so people can validate your transactions. So Party A's got a copy of the transactions, so is Party B, so they can measure them up and they can see if they're happy with what's been said. And if there's any disputes, they can obviously go back to the distributed ledger, and it'll tell them all that it'll be like a viable asset. One sense, it's a bit of a typo there. But with relation to trust as well, because it's a distributed and shared and open method of data, it's also not very private in the sense that you can encrypt the data, but generally, you can detect patterns even on encrypted data, so there's certain limitations with that. So in terms of cost, you can reduce the need for servers and clients, and in theory that can reduce security risks, or at least sort of denial of service attacks on certain things. And it's been demonstrated on the Bitcoin blockchain, if there's a significant error within the architecture of the actual blockchain, it can be rolled back to specific areas where everyone can agree that this is the new beginning, and then you can start again. So, science then. So, we're pretty interested in blockchain because we're obviously very interested in data. We've got facilities as well as partners inside and outside of STFC that we could potentially look for uses for blockchain for, and it's within our remit to always be looking at emerging technologies to try and help the scientific community. And we're also interested in research projects as well, so questions like, could we change the mining algorithm, can we create new applications and communities out of the blockchain? So I'll just go through some examples where we sort of looked at potential uses of blockchains in science, and then the little example about how we try to apply it. Then I'll go on to the Hartree Centre and go into how we're looking at using it in some business applications as well. So if you think about a clinical trial or an experiment verification, generally, somebody publishes some results and they refer to their results in a paper, and the paper is then gone through the normal academic process of peer review. With the blockchain, potentially you could capture the whole scientific life cycle, like I mentioned earlier. So you could capture the proposal, so you could capture the hypothesis, and then you could refer to the hypothesis when the results are published. Sometimes people might change the hypothesis if the results suggest something differently. You could actually do it in sort of real time as well. You could publish the data from the clinical trial or the experiment to the blockchain, which could be shared between a set of auditors or even people who could add value from the scientific community to it, and they can then collaboratively go along the experiment with you and suggest different ways of interpreting the data that you might not already be doing. So it's that kind of an audit as the results are published. And then you can capture the end result, the publications and everything, and then you've got the full trace on the blockchain. And that's important for verification, but also if you think about how science and computing relate, there's a movement, there always has been, where the physical experiments gradually get simulated in computing. So if you think about wind tunnels, so 20 years ago, the big physical equipment to simulate wind over cars can now be done through computing on the whole. If you've got a big history of the life cycle of an experiment stored on various blockchains, in theory, you could get hold of the big data side of things and start maybe mining the relationship between different experiments and starting building up simulations around that as well. Another big area of blockchains, which sort of touches on science, is counterfeit goods. So you want to trace medicines, or you want to watermark different materials such as diamonds, which is a good example. So there you can give each item, if you can get it a unique ID, so within the diamond example there's a diamond blockchain, that each diamond's got its own specific signature in relation to the light. So then you can log that onto the blockchain as being a diamond. The application there is that it's not come from it's not a blood diamond, it's a properly mined one. And then whenever the product is transferred, it's logged to a common blockchain, so you can trace the history of it from manufacturer all the way through to the end user. And then you can bring in other people to verify it as well if you needed to. So there you've got your life cycle all the way from the factory down to the consumer. And then within sensitive data, you could have smaller blockchains and then just put a third party in to audit that. So you don't have to have one specific blockchain. What I'm saying is you could have multiple blockchains across your organisation, which you could use as, say, different parts of different experiments. Or you could use a blockchain for a temporary experiment, and then when that's finished, you could get rid of it and then start a new one up for another experiment. And you could just use them as sort of secure ways to sort of validate different processes that you're going through. Another potential uses, which is a bit borderline, is sort of limited connectivity. Now you sort of integrate data when it's collected offline. So this is mainly in the sort of area of agriculture, where you want a trusted way of sort of merging the data, say within a field, taking soil temperatures or pHs. So then you would use something like a blockchain, because then you could write into the data collection the consensus of how it's all integrated in relation to maybe time or the different data that it receives. And then that's how that works anyway. And then the final one is, changing the mining algorithm. If you remember a few years ago, there used to be a thing called SETI at home, where you could put your PC, put the software on your PC, and when you turned your PC off at night, if you left it on standby, it could run the software and it could look for, I think it was intelligent life in the universe or something like that. If you've got an application where it needs to do some kind of proof of work, it could be a scientific use to be able to change it into doing something useful like that. So ISIS now. ISIS is at one of our experiments at Rutherford. It's a neutron source, and it's been running since 1985, and it's located underground. It's got 2 target stations, so the beams sort of fly around the circle, and then they go down the channels and into the specific target stations for the different experiments. So people bring in materials and things they want to test, so academia all the way through to industry, and our role is to basically help them get the most out of their time using that facility. So it goes back to the scientific life cycle, and a key part of that is being able to maximise the way they handle their data in terms of being able to process it quickly and capture and store it in the right way. So the idea with ISIS and the little experiment I did was to be able to try and look at data provenance. So how can you prove that a data that's captured on a machine and then taken off the site and then put in the publication is the valid data? You could do it, you could create DOIs for the data, but how do you really know that that is the data that was taken from the machine? So the idea was that we would look to log it onto some kind of distributed ledger, which would act as a kind of a shared log for the experiment data. So if you published some results from ISIS, say after you've done the experiment in a couple of years' time, and somebody wanted to interrogate those results, they could either go look at your physical piece of paper and your DOIs, or they could actually look at the trace on the blockchain and then if it's set up in the right way and it's trusted in the right way, they'll know that those pieces of data are real, so then it's a real anchor to the experiment. And it also allows aggregations to be broken down as well, so you can also store in any data that was used before the experiment was run in order to sort of do the collaboration, and any policies that you might have applied to it as well. So, yep.
May I have a question?
Yep.
About these blockchains, there is possible legal usage, like proving that the data are the right data, like in digital forensic.
Yep.
You need to be sure that data wasn't tampered. But is there any law right now which would specify how many devices have to share the data to be proved that it's not tampered? Or
Well, it depends on who you're trying to prove it to. I mean, if you've got a set of peers within the community that you need to prove it to, then that's your sort of limitation, I guess. If it's a financial set of transactions, then effectively within, say, the Bitcoin blockchain, no one trusts anybody. So then that's why the validation is sort of set up on a consensus, which is kind of a majority rules. And it's sort of built up within the community for that to work. It's an interesting question of trust, really, and there's been lots of research on trust over the years, and maybe this is a good opportunity to start trying to apply some of that research in a different area within how you actually do those things. Within scientific communities, this is well-established peer review processes, but we're also part in STFC of different scientific networks around different experiments. For instance, we're part of an EU project called EUDAT, which has been running for quite a few years, where we develop software for what is it, Ian? Is it sort of mainly, is it ISIS related EUDAT, or does it go across the whole lot?
There's so many partners, it's even as things to humanities with archives of ancient newspapers.
Right.
So it's very wide-ranging.
Okay. So there is communities there, and maybe this is a question that they need to start asking, is if we can capture the data in that way, how can they develop the new processes to make sure that the validation is correct? Does that answer your question?
Well,
sort of. Well, that's not bad.
So right now it's like for community sciences and this stuff, but not for like usage in the court.
In the court? So
Yeah.
you mean like forensic stuff, so computer hacking and things like that?
DEFA can catch a hard drive, he can scan data,
Yeah.
and then he has to make sure that there is a chain of the evidence.
Yeah. So that I guess
It could be used possibly to just copy to enough sources to make sure that it's not tampered.
yeah, that's one way. And you also get into the area of sort of trusted hardware as well. So if you know the source of where the data is coming from is 100% trusted, and then it's distributed between the nodes, then you can argue that it's pretty secure in terms of forensic capabilities. And there's a big research area around trusted hardware. And I think how you basically get the cryptocurrencies into a physical form is rated to trusted hardware as well. Okay, so ISIS is pretty handy because there's an API written in Python, and that basically kicks out a lot of data. So it's possible to feed that data into a blockchain, so you can start logging the experiment data and sharing it out. Yeah, so that's pretty simple. So when I did these tests, it was about a year ago when I was working at STFC in ITRAL. Pardon me. And I just did a quick scan of open source blockchain software that I could find, and I found multi-chain, which is pretty handy, and in the sense that you can create private chains from it. So it's not a cryptocurrency one, you don't do any mining. So you can create your own sort of networks of trust in relation to how you do the sort of validation and the consensus and how you effectively stick the blocks together. And there's lots of good documentation. If you go on their website, it's really well, nicely laid out. And an interesting thing about blockchain technology as well is that, and this is really gets quite confusing, is that you don't have to use its own blockchain, so you could use its own sort of governance mechanism, but then write to a public blockchain such as the Bitcoin blockchain. So you can store anything on the Bitcoin blockchain, not just transactions in relation to Bitcoins. If you're prepared to pay the mining fee, you can store any kind of data on there. Does that make sense? Yeah. So you can deploy multi-chain in Docker. And then the other one is Ethereum, which is a currency, but it's a very popular open source blockchain. And this is used by quite a few sort of blockchain emerging companies as well. One of the main reasons is because it supports smart contracts, which is a bit of added functionality from the sort of Bitcoin blockchain. There's lots of different multi-platforms that it supports as well, so I've had it running on a Raspberry Pi, but you can run it on a normal machine as well. Yeah, and it's got its own currency, like I said, and when I looked at this about a year ago, I thought, I might buy some Ethereum because they're quite new. And there's $10, and now there's $60. And I couldn't get through all the financial checks. Got hold of my passport and things like that, so I just gave up. So it's a bit of a regret there. So anyway, this is other work. So I mentioned the Hartree Centre, so that's where I work in Warrington. So with Innovate Finance, the Hartree Centre set up a thing called the Blockchain Lab over a year ago, and to be honest, it's not really got off the ground, partially due to resources. But these technologies are largely the forefront of it, and we're currently starting to look at one of the technologies from a company called Bitfury, which is sort of microtransactions. So if you look at this current credit card network, if you log a transaction that's less than something like 50p, it's not economically viable for the credit card company to process it. But the blockchain community thing, using these things called micro payments, well, micro transactions, they can reduce that to maybe 2 or 3 pence value per transaction. And they do that by taking it away from the traditional mining set of algorithms and doing sort of a side thing with it, and then putting it in as a big block. Our interest in that is putting it on a big piece of HPC and testing it. Hyperledger is the recent open source blockchain technology which has come from IBM and the Linux Foundation, and that's been in the design process for a few years, and that's something we're looking at as well. So that's probably worth a good start point. We had a project funded called Energy Clouds, which is effectively using blockchain for local energy trading. So if you think about the way the energy market's going at the moment, so obviously there's renewables, but we've also got emerging battery storage as well. And new housing estates are increasingly being planned to be self-sufficient in terms of energy. So if you imagine a new housing estate, you've got solar panels on the houses, maybe a wind turbine, a battery storage system, and maybe some industry as well, which you've got their own generation facilities. There's no reason why when somebody's at school or work, their house, which is generating electricity from the solar power, can't trade it directly to the factory local nearby or a neighbour who's in, and then mismatching the energy around the community like that. And the benefits of that is that because if you can share more data within a smaller community, because you can link it to, say, local weather in relation to solar. You could probably share school timetables in the local area, so when kids are at school. You could even share shift patterns from the factory, and as sort of the Internet of Things emerges, and you've got more and more smarter devices in your house, such as your smart fridge, your smart cooker, they can start sharing data as well, and so you can start, getting a big data kind of prediction mechanism going on, see where the demand will be for the next day in the village, and then you can route the electricity from people's houses or factories to the relevant ones which need it, and then vice versa when the demand changes. And the idea is that in order to do that, you would need to form contracts between the different parties, and more importantly as well, show where the energy went to, so people can have a trusted list of the actual transactions. So that's where the blockchain would come in. So everybody in the community would have a copy of this distributed ledger, which basically shows who's been using what electricity, where your electricity was generated from, so you can validate it and be happy where it's gone, and then you can maybe negotiate price. But what's missing off that is the actual sort of financial technologies aspects, where the pricing and the selling comes in. But effectively, if you think about all the data that's going to come from your home with sort of smart homes and increased renewables, there's no reason why you can't negotiate locally and do your own contracts to share it. Here are some commercial examples of blockchain technology, sort of 3 different ones, and how it's influenced things. So Tallysticks, remember we talked about Tallysticks at the beginning. Tallysticks is also the name of a blockchain company. When we last spoke to them, they were using the Ethereum blockchain, and they do a lot of work around invoicing using blockchain technology. So the businesses have got a sort of shared view on the transactions between them, and it's very, it's trusted in a better way. Hull Coin, or somebody I came across the other week, they actually they're based in Hull, right, and hence the name. And they're like a bit of a social enterprise where if somebody does a good thing for somebody, so there's a trusted parties within Hull who can generate Hull coins. So if you do a good deed for your neighbour, or you do some football coaching for free for your community, the football club could offer you a Hull coin. And then there's certain retailers within Hull who will then give you something in reward for that, like a free coffee or something like that. And apparently it's taken off quite nicely. It's getting a bit of momentum. And obviously, the transactions and the trust behind it allows them to monitor people who are, say, just spraying Hull coins around like crazy, and being able to guide them back and try and get on the right level. And then the final one is Bitfury, which is a big company around blockchains, and also they've got a background in Bitcoins, and they do a lot of mining, and they develop their own hardware, these ASICs chips, which are interesting in the sense that it shows how this new way of sort of sharing data and the new business behind blockchains has driven innovation in different areas. So they claim that they can create, if you're familiar with, I think it's FPGAs and things like that, customizable chips. But these ASICs chips, they say they can take them in 8 weeks from design to actual physical device, and they run specifically for algorithms. So if you're a chemist and you've got a problem that you want to crunch and it's taking ages on your HPC, you've got a bit of resource, you could go to somebody like Bitfury, get a specific chip which could process the problem a lot quicker. And you can see that's sort of from the background of designing specific chips to process the Bitcoin mining algorithm. So looking at the hype curve, you can see blockchain is almost at the peak at the moment. So there's been a lot of hype around blockchain, as you're probably aware, and generally if you talk to people, a lot of people say, blockchain is a solution looking for a problem, or if you think of too much about blockchain, you're a hammer walking around and everything's a nail to you. And there is a bit of that in the community, but I think there is signs now of the technology sort of maturing and getting real uses as well. So in summary, it's a sort of new way of doing old things. So trust, consensus and provenance are key to it. But it's really just the beginning. So you think about the other technologies went over 20,000 years. Blockchain's only been going for 7 years. There's huge potential, and for science, with respect to provenance and the whole data life cycle is something that we're interested in at STFC, and hopefully we'll carry on researching on it. So thank you very much. Any questions? Yep.
So I do really see the incentives for scientists to adopt blockchains compared to resistance to that.
Well, the incentives, if you think about sort of fake news and all the bashing of science that's going off, any mechanism which can make it easier to validate science and make it more open and harder to question, it's got to be a good thing.
Be within the scientific domain, and there's lots of sceptical members of the public.
Yeah. Well, no, I mean, if you can prove to the public that, you know, I mean, generally it's an argument, isn't it, science? If people peer review something, and you can argue the same about the data as well, but at least you can start saying that the data is there. Perhaps you can couple a lot more into the data as well. So if you talk about the life cycle, you can capture more of the life cycle. So you can reuse things as well, and then do it, obviously, the data mining piece as well.
Would you see the ISIS scientists as being able to sell this to people in other domains?
I don't know if ISIS is the right application for it. I mean, the diamond thing is a commercial application.
Diamond trading?
Yeah. And, you know, high value materials. And we do a lot of materials work at STFC, and it could be something related to that. I guess if it boils down to money, if you think about how much money is spent on running scientific experiments, if you can sort of reduce the time it takes to sort of formulate them or run them, or maybe even be able to simulate more of them because you've got more of an understanding of the data in the previous work, it could be a benefit, and that could be one selling point. Yep. Sorry.
In my little mind, I think of this as being open accounting.
Yeah.
Largely, although there is some closed accounting, as you pointed out. And Steve Ballmer has launched this week the project he's been spending many years and half his fortune on, which is sticking all the public expenditure into the public domain. And he's not used this system as far as I know. Although in this country we also have a rule that any council that spends more than £50 has to declare it on their website. Unfortunately, what they do is they send you a text file if you're asking for the information, which isn't very helpful. I'm actually thinking how this might be deployed inside an organisation that such as yours, which is involved in what Jeremy Corbyn would call corporate welfare payments, helping industry with big chunks of money, in order to make that more accountable. Shouldn't you be eating your own pudding, if that's an expression that's appropriate? Shouldn't you be? So
you're saying if we log all our expenditure to the blockchain so people can analyse it better in terms of open data?
Yes, I'd specifically like to I'd like to know how much you're spending on this stupid bus service that you're running around off.
That's quite handy, actually. Well, you know, that's more of an open data thing. I mean, that's freely available, I guess, if you do a freedom of information request. And like you say, you can get it in a multitude of formats. I don't think the blockchain would particularly help with it. If you wanted to look at...
Well, it isn't easy to analyse. People spend their lives doing FOI requests and get extremely little out of it. If it was all published in a public ledger... Or then you have a chance to analyse what the money's being spent on, and if it's being spent wisely. Because no one knows at the moment.
But you've still got the ability for people to publish it in different formats within that ledger. Unless you... I mean, the key thing is to agree a standard for how the public expense is published on the top line. Which, I don't know if that's been done or not. But, yeah, I guess, I mean, if you've got... I mean, I suppose if you can automate the process and put it into a distributed ledger, that's one way of doing it. Or, I mean, the real benefit would be when you can, I mean, with a cryptocurrency where you can trace the transaction, you know, from a sort of monetary perspective, and follow the money around completely. Then you can see it leave STFC, go into another part of STFC, and things like that. And that would be probably the real value, because then you could see, I don't know, just certain things that might be of interest to you. It's a question over there.
I can see how this would work in maybe a single organisation or something like that. But there are clearly lots of applications. So thinking about the internet as a whole, if this was adopted as the data protection mechanism for the entire internet, the data that's in the internet, how would you see that obviously we can't store the whole internet in one place. So how do you have a vision as to how the data would be hierarchically organised in order to achieve that?
I guess you would organise it by time of publication. I mean, I don't know if you'd be able to log it all onto one potentially, if you've got some kind of pointer to every new bit of data created on the internet, and then you could log it,
Yeah.
potentially you could do it like that. But I guess if you're interested in a specific domain, so I was talking to a fellow doing his PhD on sort of social media and responding to different events in the public domain. So you could maybe use a distributed ledger to, or you could have a machine learning algorithm listening to that data, and then as soon as it comes across it, it could log it to a distributed ledger, which could then share it across, different parties. But then, you're crossing into the domain of sort of peer-to-peer data sharing, which sort of exists already. This sort of trust element is sort of key to it as well, being able to validate, that it's from a regular source and that it's been added to the network going through specific checks as well.
I mean, that's the very specific problem we all have with viruses. Validating where the code that we're just about to run has come from. So
Yeah.
I can see it applied in that way. And
Yeah, somebody, I think it was Jens at work, he was talking about the whole issue of sort of certificate authorities and how the model is sort of broken, and maybe you can do some kind of distributed ledger piece on certificate authorities, and as in one way of being able to validate them more effectively than what already happens.
You could obliterate viruses using this kind of technique.
Yeah.
Yeah. But I was trying to get a picture as to how the internet as a whole would look if we decided to use this as a data transport protection mechanism. So you're suggesting some kind of hierarchy of data blocks.
Yeah, I guess if you started with this sort of CA approach, and you had a method of ensuring that, I think the current mechanism of CAs is, I'm not sure how it works, but if somebody gets hacked, they get removed from a network list or something. But I think it's sort of pretty old technology.
It's based on physical trust almost.
Yeah.
You've got a hierarchy of people that trust other people and the very top.
Yeah. Well, Jens at STFC is really hot on that. I mean, maybe he could do a talk here about it. Quite interesting.
Sorry, just on that note, because you're talking about peer-to-peer networks, and presumably there's already some infrastructure below it that distributes, that makes nodes talk to each other, right? And if you think about, other peer-to-peer sharing systems, like file sharing systems, they already have addresses and they have a way of indexing data so that certain nodes get certain things. So is that part of your technology? So when you speak about peer-to-peer, is there a physical distributed table, sort of distributed network underneath it, or is it always from scratch made tailored to a particular application?
No, if you can get, you can download Ethereum, which is effectively kind of a network off the shelf, and I guess that's got an underlying sort of mechanism doing the peer-to-peer stuff. But the sort of stuff you would add onto it is how you would do the data validation, and how you would agree which data is going to be shared. So, for instance, if you wanted to write a new block to the blockchain, which everybody would see, you go through certain steps in order to do that.
Yes, but the fact that everybody can see it means, in my head, that everybody can query it, not that everybody necessarily has to hold it. So
Yeah.
Does this allow for that kind of thinking about what was being asked? Not everyone needs to hold the full thing. If you
No.
can establish some sort of trust and some sort of ranking between nodes, and you can say, well, more.
Yeah,
trusted
yeah,
nodes
there is,
hold
yeah.
more of the.
Yeah, I guess in the Bitcoin one, there's the miners. They've got a certain degree of hierarchy above the other ones, and you would need. I guess you always need some form of hierarchy, unless you've got sort of a pure mechanism of checking things. Sorry, that was enough.
Let's say you've got government deals with 4 different companies. Each of those companies you have a chain with,
Yep.
but you can't let all 4 companies sit because of commercial confidence reasons. So can you put your end of the chain, the 4 chains together, so that you know what's going on? That's what I'm getting at.
Yeah, I guess you could do. Yeah, I mean, you could have 4 different chains.
Yeah, well, the point is you have you have to have 4 different chains to deal with 4 different companies.
Yeah.
They can't see each other's data. But you still need to bring your end together so you've got one accounting process of what's going on. Can you live those 4 chains for you and not for them?
I guess, yeah, I know what you mean. Yeah, I guess you would write a bit of software which did aggregation or something, maybe into another chain. I mean, the thing is with my understanding of the blockchain is that it's shared between all the different parties, so everyone can effectively see something. And if you're dealing with business parties that don't trust each other, you know, they wouldn't even want to see the data if it was share the data, even if it was encrypted.
Yeah, I'm not thinking they don't trust each other. You can't, because it's a commercially confidence process. They don't want a customer. They'll ultimately see it because it might mean that it's the next time the other person who's built for their contract cheaper.
Yeah.
So you do need a way of running those 4 systems, but at your end you need to know everything that's going on. So you need to link all the chains together at your end, but not theirs.
Yeah, I mean that could be, you know, something like Talistics or somebody like that's doing, adding the value to sort of that kind of application. But you know, the question is, I guess it would make sense, yeah. But I mean, I suppose you get to this stage where if you're running so many different blockchains on a sort of one-to-one basis, you know, you probably have to find a more efficient solution to do that rather than blockchain. Has anybody else got any questions? Yep.
Yeah,
You wanna-
so if I wanted to track the scientific life cycle of someone's scientific research 50 years ago, I could look at the raw data from their laboratory workbook, I could track correspondence, published papers, newspaper articles, interviews, etc., etc. It wouldn't be complete, but I'd have a fairly good sense of what they're doing.
Yeah.
If I wanted to do that to the data that's around today, in 50 years' time, that's problematic already. You know, emails are in different formats, there's Word documents.
Yeah.
At best, I might be able to get access to the raw data.
Yeah.
In 50 years' time, how are you going to get data out of a blockchain?
Well, you know, currently, like you say, the current system, if people's emails and things like that disappear and potentially even the data could be at risk.
Yeah, but at best you probably would be able to access the raw data.
Yeah.
How would I do that in 50 years' time from a blockchain?
Well, you would. I mean, if you've got, say, if you log all those different events within part of an experiment, make it part of the rules of getting the funding that you have to write certain things to the blockchain as you go through it.
Mm-hmm.
And then obviously, if you share that ledger with lots of different other parties, cross your fingers that somebody keeps it at the end of the day.
But let's say someone does keep it.
Yeah.
Do they not need some kind of, I don't know, the consensus algorithm? I mean, the whole point of blockchain, I presume, from cryptocurrency is that it's really hard to reverse engineer. So
Well,
I
it
don't
depends. I
have
mean, you
this
can say
blockchain.
you could. I mean, if
Unless
it's
I misunderstood, it's entirely possible.
if it's a sort of trusted way of doing, you know, you could define your own mechanism for logging the data. It doesn't have to be, you know, totally encrypted or whatever. If it's a sort of open science mechanism, I mean, there the key thing will be making sure that the data is open and shared, but also it's logged in a sequential way, which is totally trustworthy. You know, it's not been tampered with, and the data is correct. I mean, they're the key things there, I would imagine. And then you'd be happy to open up all the other stuff, make it easier to understand. So you wouldn't use say the Bitcoin blockchain. You would use you design your own sort of scientific open one.
But if I'm designing my own sort of scientific algorithm, how do I know the rules in 50 years' time? If someone wrote the rules 50 years ago,
Or what you mean, the rules for adding the data?
yeah.
I guess you could write a README file and add that onto the blockchain at the start, or something like that. Maybe if it's open. But you know, that's a big problem for science, isn't it? You know, I mean, with the Atlas, 50 years of Atlas stuff, when we go back, we've got the old distributed ledger, the big book. That's fantastic. We've got loads of tapes, but we can't get anything off them because all the equipment to read them is gone, and all the skills have gone as well. Yep.
It's over a decade, I think, since the EU last managed to get its accounts audited.
Right.
Would this help or damage?
I suppose if you was really strict and you got everybody to log data in that kind of way, it would make it a lot quicker to audit things because you would have it all in one place, ideally in agreed format, so you could run machine algorithms over it or whatever.
And the supplementary question is, I can't understand why the politicians are letting you do it. Because
Well-
it's going to make them honest.
Yeah, well, you know.
Point of order. That's
Yep.
a bit of a myth. It used to be that the accounts were not signed off, but the most recent accounts, I believe, they were signed off about 97% was signed off, and there were small still
Okay.
it wasn't.
All right, good. That's
So
thanks very much
it's
for that.
not the kind of, oh god, 100% of the EU budgets are not signed off.
Yeah,
So I used to believe that, and I spin it around, and I just go,
right.
I had to go around,
Well, it's not just the last year.
Hey, let's not get onto the Brexit and.
But I don't think Bitcoin is going to help with all the very high level things people are mentioning. It's a relatively low level infrastructure piece of technology, isn't it? There's certain Bitcoin applications built on top. I mean, but all the ideas of open government have to be tackled at a much higher level, policy, system.
Well, we went to an event. We went to an event. There was some people there from government, and they were talking about, would this be a fantastic way to make people who are receiving benefits not spending it on booze and fags? And in theory, you know, if you did, you could potentially, if they used a currency, if you had a welfare currency, you imagine what kind of society we'd live in, though. I mean, but if you had a welfare currency where people had to spend it as a cryptocurrency and it logged exactly what they spent it on, you could do that kind of thing, which would be, yeah, to be terrible.
They got some of the data from welfare from credit spending in the US, and they found that people were spending a higher percentage of their income on stock than the regular population. It wasn't significantly higher, but it was slightly higher, so they do log some of the data already.
Yeah, they use things like welfare checks there as well, don't they?
Yeah.
And they've got specific
But
vouchers.
they did find that actually, which is sort of plays into maybe some of the rhetoric you hear here about sort of like this benefit people, but they did actually find out that it was because people were living in basically food deserts.
Yeah.
So that was really the only way back to the economy. So I mean, what you do with data and then the policy and the strategy and context is, I think.
Yeah, it's like the whole open data argument. I mean, I think some people wanted to open data so people could, use it as a stick to bash local government, but then you need other people on the other side as well to say, look, we need this spending as well. Yep.
This is a trivial one, really. I was intrigued by your statement about a hull coin.
Yeah, yeah.
And being used, somebody would be given a coin for doing a good deed and then could go to a retailer. Now at that point I thought the Inland Revenue were going to be interested.
Yes.
Right.
Do they get passed a copy of the chain, or is it, how would that work?
Well, Hull's part of Yorkshire, and they've got to. I think at the moment they've avoided the Inland Revenue, but I'm going to meet them in a week's time, so I'd be interested to find out. But I don't, it'd be sad if the Inland Revenue got involved. Yep.
You were saying it was a fault in the chain, you roll it back to the point of the fault. That's a consensus decision.
Yeah, it is, yeah.
Is there any way you can actually turn around and say you've got 50 years worth of data, for example, on the chain,
Yeah.
that you can actually take a block out and then just adjust backwards?
If you've got the consensus, you can do it. Yeah.
But I mean without rolling it back, because rolling it back up that far might be difficult. Can you actually remove the block and adjust itself?
Probably not, because I think the way it's done from a cryptographic point of view, which I'm not very hot on at all, is that Hull has to balance out, and then you sort of screw the whole thing if you start messing about with it. So it's not quite like Lego. It's like Lego with blocks of concrete in between and girders going through the middle. Any other questions? Yep. Monetize it. There's always research grants. That's a good start. But then obviously, because the companies such as what they call tally sticks, they provide an informal in the business process of companies, and they make money off the back of that. I suppose it's all about creating business efficiencies. and being able to connect supply chains up quicker. If you think, I'm talking to a company and they are involved in automotive or aerospace, and within supply chains, there's a lot of smaller companies and larger companies, and the larger companies sometimes send requests for certain modifications, and then sometimes they send another one, and they're sometimes not as efficient as what they should be, and it sometimes plays havoc with the SMEs, but because it's the bigger customer, they can't really do that much. They've not got as much redress as what they could do. But if it was all on a safe system like this, where it's sort of automatically validated and acted as a kind of a fair play mechanism between all parties, that could be a one business process that you could monetize from it. But you know.
So you know the currency, like Bitcoin currency.
Yeah.
Limited to what, 21 million or something.
Yeah, yeah,
so
it is.
that
Yeah.
is taking its value from however many people are using it.
Yeah, it is. Yeah, I think the more it's used, the more the value goes up, which I think makes sense. And I was at an event in Manchester, and there's a guy there who's fanatical and passionate about bitcoins, and it was an event with bankers there, and he was basically saying, you know, this is what's the point in money now? You know, bitcoins are really going to take over banking, and he's pretty convinced about it. So, yeah, it's, people really see it happening. But there's legislation, there's a legislation from governments around using cryptocurrencies and things like that, so I don't think it's going to happen anytime soon. Any other questions?
Yeah, one. I understand that the whole point of this is that each node has the copy of the data, or access to the data. But what about the security concerns? I mean, there was the energy cloud example, and if you would put there the kids' schedules or factory worker schedules, the access to this data could be used to know when to rob them.
Yeah, totally, yeah. It's not very private. I mean, that's probably part of the reason why you look at it on a local scale. So there's a sort of element of trust between the local community. But, you could encrypt it, you could mask it in some way. You could have some kind of piece of software which interprets it and does some kind of randomization on the data, so you can sort of hide it in some way. But it's the privacy aspect of it is not very strong. So, there's always, people can look at web searches in America over a period of time and start identifying individuals. So you can always go through those things. Yep.
If I could just add a comment to that, so that's a big problem when businesses are doing interactions. So to accommodate the same problem that was mentioned earlier, some of the technologies that you mentioned, so the hyperledger fabric, things like Corda from R3, are specifically designed to address that problem.
Right.
So you can have interactions between businesses, so you don't have to share the whole set of data between everybody, direct channels that are much more private. So some of the latest technologies are much better addressing.
Yeah, that's a good point. So that's, the modifications that are added onto the, the blockchain in order to suit the different business processes. And R3, if you don't know about it, is a big sort of organisation which is pushing a form of blockchain, which was backed by most of the major banks. And within, the financial technologies domain, it's seen as a pretty significant player. Yep.
Because of the peer-to-peer nature, am I right in thinking it's only really useful on small amounts of data?
No, I think you can put pointers to larger bits of data off that. So, you can store anything on it really.
So if you were handling the data from your square kilometre array, you just have the metadata in the blockchain.
You would have, say, the hash of the data or something like that, which you can trace back to the original data. But it would allow you to show that that data was, say, created at that specific time under so-and-so conditions or something like that. Any other questions?
More an observation. It struck me that thinking about Ben Buldick, who wrote a book called Bad Pharma, which he talks about scientific trials and trying to get all trials on drugs published. And of course, one of the things, when you start doing experiments like that, you don't actually know what the data's going to be, obviously. But if you can then demonstrate that the data, the raw data has actually all been published, which you can if you use something like blockchain to demonstrate that it hasn't actually been tampered with between that and the stage where you process it. Because what happens at the moment, obviously, is that you can then, if you're the drug company who's sponsored it, only publish the bits of it that suit your.
Yeah, that's a big thing.
That's true of lots of science. That actually you don't know before you publish the experiment. The value comes from the bit between the raw data and what you get out of it.
Yeah, and as a research council, that's the kind of thing which you would think STFC would be interested in, because you can get real value out of the stuff that doesn't get published as much as the other stuff.
That's also true of all the things, controversial areas, climate change, drug stuff, almost anything like that.
Yeah. Thanks. Any more?
I'd just like to thank Tom for sparking a very interesting discussion on this. My feeling is, I think as you alluded to, it's probably, as they described the laser a long time ago, as the solution in search of a problem. So it'd be interesting to see how this evolves in time. And it's good to see that you're actually looking at all these sort of possible ways of using this. So thank you very much.
Thank you. You're welcome. If you want to know any more information, just send us an email, and you're welcome to visit Raleigh or Hartree, whenever you like.
If anybody wants CPD